Hello, in this lesson, I'd like to go over two questions. One is you can see on the right-hand side. If you cannot see, that's okay. I'm going to put up these two questions on the screen. Okay, we're going to go over these two questions. Divided by x squared plus x plus 1. Okay, the second question, where we're going to find the derivative, is y equals to x raised to the power of cosine x. All right. So before we start, okay, I'd like to go over the first question first. And there are two methods to do this, okay? Two methods. The first method to do this is to just differentiate as a quotient, okay? So differentiate it as a quotient. And how can this be done? Well, we're going to differentiate, according to the formula of quotient, the quotient formula. Okay, so the denominator will be squared. So that's the denominator. And the numerator, we're going to differentiate that part. Okay, so that part will be differentiated with the numerator and multiply the denominator. Denominator is unchanged, so we can put it in the front. Okay, so that part is not differentiated. So this is plugging the formula. Subtracting the numerator is unchanged, and then we differentiate the denominator. Okay, so derivative. And normally this term, this step, you can actually skip. Okay, so we're just going to differentiate the denominator. So this will be the structure of applying the formula for quotient, the quotient formula. Okay, quotient rule of derivative. And next, okay, so we're gonna work on the details. Okay, work on the details. On the details, you can see that part is going to be a product rule. Okay, so this is going to be a product rule. So product rule is going to generate two terms. So we're differentiating that part, right? So product rule, and so we derivative of e to the power negative x, that's going to be chain rule. So that's going to be e to the power negative x, and the derivative of negative x is a negative 1 in front of it, and cosine square x will be copied. Okay, plus there's another term. Okay, so this time we're going to differentiate cosine square x, and e to the power negative x will be kept unchanged. So we're differentiating cosine square x. Cosine square x is, of course, this is a chain rule. It equals to 2 times cosine x, and then we differentiate cosine x, which is giving us negative sine x. So that finishes the derivative for just this piece. Okay, so these two are the same. And differentiating x squared plus x plus 1, right, which is this piece, is going to give us 2x plus 1. All right, so that's the consequence of differentiating by quotient rule. And then we continue to simplify. Okay, we'll continue to simplify e to the power negative x. E to the power negative x can be factored out. And there's a negative e to the power x that can be factored out. So that's factored out e to the power of negative x. But before we do that, right, look, there's a negative sign here. We may just bring this negative sign to the front of it. So that's a negative. And bring the 2 in, I'll just leave it there, okay? So this piece actually is 2 times sine x times cosine x. And so what we can do is that we can factor out negative e to the power negative x from the bracket. So we're going to factor out this piece. So that's going to be turning into positive. So negative e to the power negative x. So this need to be in parentheses. And we can bring the whole of it in the front. Okay. And there's a negative e to the power negative x here, e to the power negative x over here, negative. So we can factor this out, right? We can factor this out. So the whole of it is going to be curly bracket. Okay. Well, if you change this to parentheses and remove the bracket, and the curly bracket can be replaced by bracket. Okay, but all these doesn't matter. We factored out negative e to the power negative x. So we can remove this parentheses by this time. Let's try to reduce the inside. Okay, let's try to reduce the inside. The inside, okay, what you can see is that there's a cosine x squared, right? Cosine x squared, there's a cosine square x here, right? And inside this parentheses, we can bring out the cosine x. Okay, so we're gonna bring the cosine x, so cosine x, bring a cosine x outside. So there's a cosine x squared here, there's a cosine x here. So we can factor out the cosine x. So bring this one of the cosine x outside. Okay. And what else can be factored out? What else can be factored out? Well, not much, not much. You can still try it, right? And yeah, just leave it at that. So that's the, we leave it like this is because I don't want to do too much algebraic things at this point because there's not much it can be factored out. But you can also see the complexity of this way of factorization. Okay, so this is the first method to differentiate y. Okay, so this is a method 1 by quotient rule. The second one, we're going to do method 2, and this is by logarithmic. Method. Okay, logarithmic method. So what we do here is that we're going to take a logarithm on both sides. We're going to take a logarithm on both sides. So there's a typo here. So ln y equals to ln the whole of the right-hand side. And we're going to apply product rule, quotient rule. Okay. Excuse me. We're going to apply quotient rule first. Quotient of the numerator subtracting ln of the denominator. And the first term can also be applied product rule. The product rule can apply to this first term. So that's going to give us e to the power negative x plus ln cosine square x. Okay, so put this in parentheses if you need to, if you want to. This one you don't have to. Okay, and keep going. We can apply power rule. Power rule is applied to it, so this negative x as a power is going to go in the front. And the square as a power can go to the front. Okay. And ln e equals to 1, so there. All right. So now ln y is equals to, right there, equals to the logarithm on the other, the result after logarithm is being taken. So next, from this point on, we take a derivative. Okay. So ln y, so that equals to the derivative of the whole of it. Okay. So the derivative of the whole of it. I'm going to put all of it in the bracket so you can do one at a time. And you can also skip this step and directly taking derivative. Taking derivative. When you take a derivative, the derivative of negative x with respect to x, that's going to be -1. The derivative of 2 times ln cosine x, that's going to be 2 times, right? Chain rule, so we differentiate ln, so that's going to be 1 over cosine x. And derivative of cosine x, that's going to be giving us a negative sine x. And then subtracting and derivative of ln x squared plus x plus 1, that's a chain rule again. So that's going to be equals to 1 over, right? And then you would differentiate the whatever in the parentheses as 2x plus 1. And on the left-hand side, you're going to have y on 1 over y. Okay, this is too long. Sorry. Okay, the left-hand side is 1 over y dy dx. dy dx. So by this time, you can go straight here, really. From here, you can go straight here, right? So the logarithm part is finished. It's finished. I'm sorry, the derivative part is finished. Then it comes to the algebra part. So we're just solving for dy dx to multiply both sides by y. And inside the bracket is the whole of that. And of course, we're going to reduce it. Okay, so 2 times, we can 2 times, this is negative sign. So negative sign I'm going to put in the front to remove that. And this sine x over cosine x, right? And we can put the 2x plus 1 on the top and remove the parentheses there. And you can even sine x over cosine x as tangent x. By this time, one more thing to do. And that is replace y by its equal. Okay. Replace y by its equal. This is the y right here. Right, so that's the final answer. Well, remember we had an answer earlier, right? And these two do look a little bit different. Can they transform one from one to the other, right? Because we got this answer here, right? And that's final. How come the first method we get a different answer, right? So let me box this. That's our final answer. So let's see if we can transform first answer to the second one. They should be the same, right? Well, in order to do that, this is a perfect opportunity to practice your algebra, okay? We obviously need this, right? We already have a cosine, we already have a cosine x. We need a cosine squared x. So we need to extract cosine x from here. So we're going to take this cosine x out. If we take this cosine x out, but this one does not have a cosine x, right? So we need to have a cosine x here divided by cosine x. Okay, so now we can take these cosine x out. We can take this cosine x out. And we can take this out. We can take this cosine x out finally. And of course, that makes cosine square x. Okay, this is just a game of matching. Okay. There's no negative sign in front of it, right? So I'm gonna just leave it out there. So by this time, I'm going to have my numerator, partial numerator there. Denominator, I have two of these, right? So I'm gonna bring one of them under. And the other one would be still stays under. And we're going to deal with this piece to see that will match the bracket in here. Okay. So now this is obviously tangent x, right? We got tangent x. And then we just take this piece, divide into the top. And we take this piece, divide into this piece, okay? And we're almost there. Okay, so now I'm gonna keep this part unchanged. And inside the bracket, I'm gonna do that splitting, right? So this piece divide into the whole of this piece. So that's gonna be 1 plus 2 times tangent x plus, okay, the latter, which we have 2x plus 1 divided by x squared plus x plus 1. Does that make the match? Almost, almost. There's a negative sign in front of it. If I bring that in, right? If I bring that in, and it will match perfectly. But you know what? I think that negative sign is better stay outside. But either way, I'll show you that you're gonna have that match. Okay, you're gonna have that match right there. Okay, hold on. So this is I bring that negative sign over inside the bracket so they match perfectly. That means either method we did, well, both methods we did are correct. Okay, which way is easier? It's obvious the logarithmic method is easier. If you, because I noticed people did the quotient way. That's why I covered the quotient method in this lesson. Okay. All right. Let's look at the second one. The second one is no-brainer. We're going to use logarithmic differentiation. You can't use power rule. You cannot use the rule for differentiating exponential. So you have to use logarithm. So ln y is equal to ln x raised to power of cosine x. And then that equals to bring down the power, so ln x, right? And we take a derivative on both sides. We're differentiating ln y. And that equals to differentiating on the right-hand side, which is going to be product rule. So we're differentiating cosine. We have a negative sine x, and then ln x plus cosine x, and differentiating ln x, that's going to give us 1 over x. On the left-hand side, we're gonna get 1 over y dy dx. dy dx equals to, on the right-hand side, we can switch term with these two, so we don't have to, we can write it this way, okay? It's a switched or commutative property between these two, subtracting sine x multiply ln x. And multiply y on both sides, and we're almost done. dy dx equals to y multiply both sides by y, right? And there, okay, replacing y by its equal, which is, boom, we're done, okay? So that's the how to do on these two. Thank you for watching.